Hello and welcome back to Analytical Instrumentation. Today we are going to learn about instrumentation of infrared spectroscopy. IR spectrometer is basically of two types, either dispersive or Fourier transform. So in this video we will discuss only the dispersive IR spectrometer. So this is a block diagram of dispersive IR spectrometer. From IR source, the radiations will first reach to the mirror. These are the mirrors and get reflected to these mirrors and then will pass to the reference or the sample cell. So why are what is the use of these mirrors? Basically, to provide equal amount of IR to both reference as well as the sample, we are using these kind of mirrors. So from this reference or the sample cell, again the radiation will be reflected by the mirror to the chopper. Chopper is basically to split the beam. Okay, so here from this chopper it will again uh, goes through the towards the mirror, either reference. Now from the mirror it gets refracted towards the grating. I have already told you about the grating. It is used to select the wavelength. So it acts as a monochromator. So from grating the radiation will then enter to the IR detector. So the basic components of IR spectrometer, dispersive IR spectrometer, are your source of radiation, monochromator and detector. Starting with the source of radiation, first is Nernst glower, in which there is a rod made up of rare earth oxides and it is sealed with platinum leads. Basically, platinum leads are used to provide electrical connectivity. There is a negative resistance. What does negative resistance means? It means that the resistance decreases with increase in the temperature. That is why at room temperature, Nernst glower is non-conducting. So we must heat the element, this rare oxide elements, to emit radiation. And once it start conducting radiations, the maximum radiation would be at 1.4 micrometer or 7,100 centimeter inverse at about 1500 to 2000 degree Celsius. The second source of radiation is glower. In Nernst glower, the rod is made up of rare earth oxides. Now here, the rod is made up of sintered silicon carbide that is heated to about 1300 to 1700. So it possesses positive coefficient of resistance. Unlike Nernst glower, here the resistance increases with increase in temperature. So the maximum radiation occurs about 1.9 micrometer or 5200 centimeter inverse. But water is needed to cool the electrical contacts in order to prevent arcing. Electric arcs, basically, here is the sintered rod and water is there to keep this rod cooled to avoid sparking. Now, glower source is more intense than Nernst glower, but is its intensity decreases less rapidly. Like the intensity of nuanced glower increases more rapidly than the glober. So the lifetime of nuanced glower is less than glober, and glober is used for longer wavelengths that are for more than 15 micrometers. So in short, although the intensity of Nernst glower is more than glober, but glober is used at longer wavelength because the intensity of glober decreases less rapidly as compared to the Nernst glower. Third is incandescent wire source. So here a nichrome wire, a tightly wound nichrome wire is heated at about 1100 Kelvin, and this thermal energy or heat is provided by electric current. So the radiation, although the radiation produced by nichrome wire is less intense than glober or Nernst glower, but the cost, like as you have seen that in nichrome, in Nernst glower, rare metal oxides are used, and also it is negative resistance. So uh, it cannot be operated at room temperature, right? And whereas in glober there is a positive resistance, but we have to cool the rod. So there is nothing like that in nichrome wire. It is basically it requires no cooling and is maintenance free. Its lifetime is high and it is less expensive. In place of nichrome wire, sometimes rhodium wire is also used, but it is more expensive than the nichrome wire. Monochromator and grating. So monochromator is a device that is used to narrow down the spectrum of electromagnetic radiation to the to our desired wavelength or frequency range. So how it can be done? It can be done using prisms or gratings with that are attached in a particular manner with mirrors and filters. So narrow slits can be useful to produce a better resolution, but wider slits allow more radiation to reach the detector and enhances the sensitivity. So both cannot be possible. So we have to compromise in whether resolution part or the sensitivity part. For more details about the monochromator, you may go through my first video, Introduction to Spectroscopy. The link is given in the description box. In that video, I have already mentioned about the different sources of radiations used for different spectroscopic techniques, monochromators, prism, diffraction gratings. So you may go through that. Now, talking about the detectors, I have already told you about the detectors in my previous video. The link is given in the description box. So, IR detectors are basically of two types, thermal and photon. Thermal are divided in again into three: thermocouple, thermistor and bolometer, and pneumatic device. Whereas Photon is divided into two, photovoltaic and photoconductive. So thermal detectors, as the name suggests, it measures the heating effect produced by IR, and it is basically dependent upon the physical property change. For example, there is expansion of a non-absorbing gas in Golay detector or pneumatic devices. Thermistor works on electrical resistance, change in electrical resistance, and Thermocouple measures the voltage at junction of dissimilar metals. Whereas photon detectors basically measure the interaction of IR radiation, basically the electrons or photons that are used to excite the matter to its from its ground to the excited state. So small current or voltage can be generated using the photons. Thermal detectors provide linear response towards a wide range of frequency, but it also exhibits slower response times. So this is the advantage of thermal detectors, that the response time is low, but the sensitivity uh, of thermal detectors are also low than photon detectors, that you can consider as a demerit. First, we will discuss about the thermal detectors. So the first is thermocouple, in which there are two dissimilar metal wires. Commonly, antimony and bismuth wires are used, and there is a temperature difference between these two, the opposite poles attaching these two wires. So this junction is hot, we use hot heat sources, and this junction is cold. So due to this temperature difference, a potential difference will develop that can be measured using voltmeter. So when there is a change in this voltage, it can be measured using this voltmeter due to the analyte. The changes due to the analyte will be measured using voltmeter. And also, when thermocouples are connected in a series, so they are known as thermopile. And the response time of thermopile is less than thermocouple. Next is thermistor and bolometer. So both of these detectors rely on the temperature dependence on electrical resistance. Negative coefficient of resistance, basically, that is, the resistance will decrease with the increase in temperature. So as we all know, to measure the resistance, the most preferred choice is by Wheatstone bridge. So in thermistors, sintered oxides of cobalt, manganese or nickel are used using Wheatstone bridge. So in now bolometer, it consists of absorber, a layer of absorber, which acts as the resistance thermometer. Uh, so after absorbing the radiation, it is also connected with the thermometer, resistance thermometer. The radiation would pass through the thermal reservoir. This thermal reservoir, it is kept at constant temperature, so it is cooled using nitrogen or other uh, techniques. So the response time is basically proportional to the ratio of the heat capacity of the absorptive element used in the absorber. Here also the change in the resistance is measured using Wheatstone bridge. So both thermistor and bolometer works on the principle of Wheatstone bridge. So the advantages of using these over thermocouples is the response time is less, resolution is improved, scanning rates are faster, but the sensitivity is low as compared to the thermocouples. Pneumatic detector or Golay detector. It is basically an optoacoustic detector where we use an IR absorber and there is a gas filled cavity. So when IR radiation is absorbed, it heats the surrounding gas and will result in the expansion of this gas. So there will be a pressure on the membrane, right? So this is detected by a signal. This is detected by signal producing in photodiode. As due to the deformation of the membrane, the radiation will also get reflected, and this reflected radiation we will detect using photodiodes. The other type of detectors are photon detectors that I have already discussed in details in UV visible spectroscopy. So basically they are divided into two: photovoltaic detectors and photoconductive detectors. Here in IR, photovoltaic detectors are GE, mercury, cadmium, terbium, telluride. Uh, In photovoltaic detectors, basically the photodiodes N type, P type to create a junction. These are used. You can go through my previous video of uh, of photovoltaic detectors in UV visible spectroscopy to get an idea, a better understanding about these. And the other type are the photoconductive detectors. So the photoconductive detectors used in IR are PBS, PBSC. So, as I have discussed earlier, that infrared radiation, the source of radiation, is basically dependent upon heat, hot wires, uh, mm, hot bulbs are used. So, the energy distribution is maximum at 100 to 2000 nanometer, that is near IR range, but when it moves towards the mid IR range it get decreases. And we all know the most important region of IR spectrometer is mid IR region, that is 2 to 15 micrometers. So the intensity of radiation is less in the mid IR region as compared to the near IR region. So to overcome this thing, large slits are used, but as I have already discussed that large slits can increase the sensitivity, but the resolution will get decreased. So in order to increase the through output, interferometer is used. So, uh, we will discuss about the Fourier transform infrared spectrometer in the next video. So, these are the references. Thank you.